Good morning, Jean-François from Chrysalide Engineering. We'll be looking at the stepper driver board I designed some time ago, which is 2-channel output, 2 amps up to 30 volts, using a microcontroller which is the CH32V003. It's a 20-pin TSSOP package, which controls 2 stepper drivers from Rohm. We see the datasheet over here, which is from 8 to 28 volts up to 2 amp nominal current. It has all this configuration from the pins. And we have actually wired them to the microcontroller so that we can fine-tune the current and the mode for the stepper driver. Quickly reminding on the board design, we just have a power stage with a buck and a LDO to make our stabilized voltage for the microcontroller. We have the power input protection with a diode and a fuse. This supplies the stepper drivers and the regulated voltage provided to the microcontroller. We have a crystal on board. We have a ports for the external control of the motors. The ports are wires to the microcontroller, and the microcontroller handles the drivers. It has direct connection to all the configuration pins and the direction and step pins for the drivers. The microcontroller is 100% loaded on the pins. We just have the enable, which is a high impedance control of the drivers, which is wired to the external pins, and the microcontroller doesn't handle this particular pin. This board has a port for the microcontroller connection, microcontroller control, and for serial communication and programming of the microcontroller. This is the complete schematics for this microcontroller with our power stage, with our input port, microcontroller and crystal, stepper driver and filters for the PWM from the microcontroller to the stepper current reference, and the digital pins used to control the mode, the bypass capacitors as needed for the driver as stated by the manufacturer, and the shunt resistors, which are 0.3 ohm for measurement of the phase current, the terminals for the motors, test points, fiducial mounting holes. This board has been fully manufactured as a prototype and will be tested shortly. And it is possible to assemble the boards back to back to get a 4-way control and have just one of the board populated with the power input and the fuse to add 2 channels so that we have up to 4 stepper motor control. It will be used for the CNC and for 3D printer projects. If we review the datasheet from Rohm, we see that it's up to 36 volts, which will be actually used up to 34 volts only. Peak current 2.5 amp, nominal current 2 amp. We have step and direction, mode 0 and 1 pins, enable. Enable pin makes the output high impedance, so it opens the circuit on the motor side. Vref sets the current reference for the output driver. The RC is used for the oscillator, internal oscillator. And then we have the output for the motor coils. We have the reference current from the PWM filtered out of the microcontroller so that we can adjust the current on the motors. Power supply and bypass capacitors. And we can control full step, half step, 8 or 16th of step. This board actually uses these pins from microcontroller so that we can easily adjust them, configure the driver remotely. The pins are shown in this table, and we see motor excitation mode can be tuned. We see that Vref is the output current setting. We can choose the current decay mode, and we see the possible configuration. The chip handles a slow decay, fast decay, and mixed mode, and this has to do with how the current is controlled on the motor side. And this can be tuned by the microcontroller. If we have a quick look at the layout, we see the power tracks, which are thick, fuse diode, and 5mm terminals, 2.54mm header for the external control, and for the programming and serial communication port. our test points, crystal microcontroller steppers, mostly surface mount and 2-layer. I'll be publishing more on this board and the performance of the drivers, test results on the various configuration. We have a channel for our selling product, which is under the description below. The LC website, which is a store. You can get some of our boards in there. And we'll be back with more testing on this particular board and follow up on the CNC and 3D printer project. Thanks for your presence.